All right. Hi. So we we start our discussion of lecture series number 7, which is centered around the central processing unit. And specifically, our focus is going to be on the so-called CPU or central processing unit instruction cycle, otherwise referred to as the machine cycle. The idea is to understand exactly how instructions associated with software programs currently loaded into memory are executed by the computer system or by the CPU. Now, a quick reminder that we're coming from sort of situation where we had a thorough discussion of the so-called von Neumann architecture, right? And we discovered that the so-called von Neumann architecture is fundamentally composed of 3 core functional units. Specifically, we had a thorough discussion of the input unit, the output unit, and we did mention that the input unit and the output unit are sometimes perceived to be one component really. So input-output unit, the central processing unit, and the memory unit. All right, so the outline of the lecture series, a pretty short lecture series, is as follows. And what we've done is we've actually split this lecture series into 3 core segments. The first part is essentially going to be more or less a revision session, really. A revision centered around the life cycle associated with your typical computer software program, right? So we want to remind ourselves of what actually happens from the point in time when you double click that piece of software so that you execute it, right? Up to when we get to see a result as we are interacting with a piece of software. And then we'll emphasize the role of the so-called central processing unit or the CPU, after which we immediately transition to discuss the key phases associated with the so-called machine cycle or CPU instruction cycle. Great. So 2 key ideas associated with how modern day computer systems work are fundamentally the so-called stored program concept and the von Neumann architecture. We did mention that the von Neumann architecture is actually dependent on the key ideas around the stored program concept. Key to this whole notion of the stored program concept is the fact that a computer system is perceived to be this fixed hardware platform which executes a fixed set of instructions, right? And if you remember from lecture series number 6, what we further discussed was that the fixed set of instructions are collectively used to come up with operations that are associated to a piece of software, a computer program. And then the operations will, of course, be the basis of these building blocks that will eventually comprise the piece of software. I keep mentioning the fact that this is a very simple idea, very basic idea, but extremely powerful. All right? You will see this very, very soon once we have a discussion on the so-called MIPS instructions architecture. The core set of instructions comprises, if my memory serves me right, less than 200 instructions. But with those 200 instructions, you are able to perform complex operations. You're able to build complex programs, right? Programs similar to Oculus, for instance. Programs similar to Chrome, right? Using the fixed set of instructions. And if you think about it, really, the 200 or so instructions, for instance, associated with MIPS, would be used in various combinations, right? So a typical operation associated with a piece of software might just involve using 3 of those 200 instructions combined in a certain order, right? Extremely powerful idea or concept. And then we also highlighted the fact that the von Neumann architecture actually comprises of certain key functional units, right? Specifically, these functional units are input-output unit, the central processing unit, and the memory unit. And really we went further to discuss that there are auxiliary components that we tend to find on the central processing unit that are instrumental or fundamental or important during the discussion of the von Neumann model, right? So things like registers, for instance, right? I mean, of course, there's more components that you typically find on the CPU, and these will eventually manifest themselves as we further discuss the deeper layers of this abstracted computer system, right? So things like ADA, for instance, will come up, things like the multiplexers. I think we mentioned specific registers such as the program counter and the MBRs or the MARs, but we also mentioned that there are actually additional registers that you tend to find there. Our discussion of registers was solely centered around what we termed or what are referred to as special purpose registers, right? These are important insofar as the functionality of the CPU is concerned. Great. And seeing as we in this particular lecture series, we're actually discussing the instruction cycle, right? Essentially how instructions are executed by the CPU. Another important idea that we need to remind ourselves of is the sequence of events associated with execution of so-called software programs or computer programs, computer software. A reminder that when we install software on a computer system, the installed files, right, the dependencies associated with that piece of software will be stored on secondary storage, so on your hard disk, right? And so once you successfully install that piece of software, it will reside on your hard disk, and every time you want to run it or execute it, what you do is you double click some sort of shortcut, right? So in my case, if I want to run a piece of software on my Kubuntu installation, what I'll do is I'll go to the equivalent of the start menu here, and then go on applications, right? And then choose the piece of software or application that I want to execute. Something else that I find a lot easier is I can literally just search for the application here. So if I want to open up Firefox, I'll just click on Firefox, and then Firefox is executed. Now, what we're saying is that there's a lot happening behind the scenes, right? So things like, I do apologize, my machine is slowing down again. Things like the piece of software is residing on secondary storage. Jesus Christ. I do apologize for this. I guess I'll have to restart this screencast. I hope I don't, because I really don't have the time to start restarting these things and splicing up this stupid screencast. Okay, great. So I hope this doesn't stop. I hope it doesn't. This is the part where you pray to God or something. But anyway, so key ideas around how a computer program is executed is once successfully installed, it obviously resides on secondary storage, right? So from secondary storage, you double click a piece of software that you want to execute, and that piece of software is going to be loaded into memory. It is at this point that the idea that a computer program is made up of individual instructions becomes extremely important, because it is from main memory that the CPU, well, in conjunction with the operating system, really will be able to execute the program one instruction at a time, right? So in this, right now, one of the software programs that is in RAM is Ocular in my case, right? As I'm interacting with Ocular, the instructions associated with Ocular being fetched from RAM. Ocular is right now, Ocular is in RAM, right? As I'm interacting with Ocular, instructions are being fetched from RAM and then executed by the CPU. One instruction at a time. Very simple ideas, but extremely powerful, right? So very, very, very interesting stuff here. All right. And then another important idea to keep at the back of our minds as we're discussing this lecture series is really the role that the central processing unit plays insofar as execution of programs is concerned, right? And we discussed this in lecture series number 6. Our discussion was fundamentally focused on the control unit, the arithmetic logic unit, and the registers, which happen to be subcomponents that you typically find on the central processing unit. So the decoding of the instructions, right? The decoding of this instruction is done by the control unit, yeah? And then the actual execution of the instruction is performed by the arithmetic logic unit. Yeah. All right, but it turns out really that the so-called CPU, right, the central processing unit, is nothing more than one of those physical components that comprise the computer system, right? I don't know if people remember the fundamental differences between computer hardware and computer software. What we actually mentioned during our discussion of computer software and computer hardware, trying to distinguish the two, is that in fact, when it comes to hardware, there are various hardware components that collectively make up this thing we are calling a computer system, right? And in terms of the CPU, really, it's a really small component that literally fits on your palm here, on a human being's palm, and you typically find it on the motherboard somewhere. Now this, granted, this screenshot, this image on the current slide and the following slide here it corresponds to a desktop computer, which is of course a microcomputer. So it's somewhat slightly larger than what you'd expect to see on a modern day smartphone, for instance, right? But the idea is the same. So your CPU, a small little component, the small CPU chip will be slotted somewhere on the motherboard, right? So there is a slot that's referred to as a CPU socket, right, where the CPU sits, and it turns out that the socket where it sits really has on top of it what's referred to as a heatsink. Because the CPU performs a lot of computations, it heats up. When it does heat up, these computer systems are implemented in such a way that the CPU is cooled in a certain way. One of the ways it's cooled is you have a heatsink that absorbs the heat, and then on desktop computers, you typically have a fan, right? The fan that cools down the heatsink. Great. Again, just to try and underscore this whole notion of the three crucial components, subcomponents that comprise the central processing unit. Control unit is the one that decodes the instruction, right? So how the CPU would need to know what this instruction is. The control unit on the CPU will be able to check the bits that help it distinguish what sort of opcode is associated with the instruction, and then it will be able to tell the ALU to say this is a sort of operation that should be performed. Is it an add operation? Is it a subtraction operation? Is it a multiplication operation? Is it a logical operation, for instance? Is it a branch? Is it a branch operation, right? Very interesting ideas which we revisit, by the way, as we're discussing the deeper layers of this abstracted computer system. But for now, control unit decodes instructions. It also coordinates the retrieval of operands in the case of operations that are mathematical in nature or that involve arithmetic operations, right? So if you're adding two numbers, the two numbers would be the operands, right? Great, and then we had a discussion of the arithmetic logic unit, which we said does nothing more than just add numbers or really does logical operations, right? And then finally, we introduced this whole notion of registers, and really our discussion of registers was restricted to so-called special purpose registers, so the program counter, the memory buffer registers, memory data registers, and the memory address registers. Pretty soon we will discover that there are other additional special purpose registers, right? So I'm not sure if we discuss this, but you have things called accumulators, right? Which all sit on the CPU. It turns out there's actually more components on the CPU. So things like cache, right? On most computer systems, both level 1, 2, and 3 caches sit on level 1 and 2 caches will sit on the CPU. All right. So just a brief recap on some of these important ideas that will help us understand the machine cycle, the CPU instruction cycle, this whole notion of the life cycle of the the typical computer program, right? So the trip it makes from secondary storage, right? The trip it makes from secondary storage, where it permanently resides, right? It sits on secondary storage. Just assume, I guess not 3D, but I'll just say secondary storage. It's sitting somewhere on secondary storage. This piece of software is sitting somewhere on secondary storage. And then from secondary storage, right? My drawing is horrible. From secondary storage, once you double click that program, it gets loaded into so-called RAM, right? Which we discovered is volatile. So it is loaded from non-volatile memory called secondary storage or computer storage, right? Loaded into volatile memory called RAM. It is from RAM where the individual instructions are executed by the CPU, one instruction at a time in sequence, right? Very important idea. And then the other things we discussed or recapped in this portion of the lecture series is the role that the CPU plays in the execution of the program, right? And specifically, our focus was on those key components: the control unit, the arithmetic logic unit, and the registers. These are important because they'll pop up during our discussion of the machine cycle itself. Great, I'll pause for now, and then I'll see you in the next part of the lecture.